This morning was a great morning for engineers, because we heard about civil engineers, and we heard about cyber engineers, and we heard about retired engineers, and now it's time for manufacturing engineers. So Michael and Steve are my colleagues there in manufacturing engineering, and I work on qualitative research about decision making. And we noticed that one of the big decisions that is going on is about automation. It's about, will machines replace our jobs? Spoiler alert, I am not going to tell you whether a machine is going to replace your job during the next 20 minutes or so. We'll just have to figure out that question offline. So, when you go and read the papers, whichever papers you read, or look on the BBC, there are two big opposing narratives about automation that we're seeing in the world at the moment. The first one is a positive one. It's jobs will change, not disappear. We're avoiding offshoring because we're able to keep a lot of activity in one place. There's a global productivity increase. There's more wealth creation to a society. Machines are a good thing. And the other one is jobs are disappearing. The rate of change is unprecedented. We can't cope with this. We can't adapt. We can't build the skills that we're going to need to live in this automated world. And in the long term, we don't really need people anymore, which, given that there's going to be about 9 billion of us by 2050, is kind of problematic. And we looked at that and we thought, this is a little bit polarised. And the numbers involved are really dramatic. So this is work that was put together by the MIT Technology Review, and they looked at reports in the sort of grey media. So a lot of these are industry reports, and they looked at jobs lost, jobs gained, and the numbers are big, and the numbers are all over the place. And we thought they can't all be right. I mean, just mathematically they can't all be right. But there's something happening here that we need to understand a little bit better. And it's significant because people are making decisions based on these numbers, and the numbers are clearly wrong. So, or at least some of the numbers are probably clearly wrong. So policymakers are trying to choose, what should we do about the prospect of mass unemployment? What sort of education should we provide? What's our industrial policy? Businesses are thinking about their investment plans. What do we invest in? What do we do about the uncertainty of automation? What change do we need to prepare for? Will we be put out of business altogether? Will the industry, never mind the jobs, be replaced by machines? And what does it mean for the people that we work with? And of course, there's a societal implication. If we need to prepare for a world without work, what will it look like? What do we need to do? Who's threatened by these changes? Who's going to benefit from these changes? Because a story like that, there's going to be winners, there's going to be losers. Which side am I on? So we thought we ought to really understand what's actually going on here. Where do these numbers come from? What does it mean for decision makers? What can we do? So we started to kind of disembowel the estimates that we saw. And the first thing we did, we looked at the literature, because we're good academics, and some of us are. Some of us are trying to. There's been a sort of explosion in publications since about since 2013. So in the last 5 years, we've seen more or less a doubling every year of papers based on these sorts of estimates. And we went, okay, what happened in 2013? And what happened in 2013 is a couple of academics from Oxford published a working paper in which they'd done a really sophisticated piece of analysis and come up with the first sort of prediction, which was that 47% of US jobs were at risk. So we're a bit like the US. Look side to side, one of those people will be, in fact, both of those people will be going, because obviously you won't be replaced by a robot, it'll happen to someone else. So we started to look at what are the assumptions underlying that model, because there's more or less the same assumptions underlying all of the models. They start from this paper by Frey and Osborne. The first one is that they did some pretty sophisticated analysis of the ability of emerging technologies to undertake human tasks. So, can we replace hands? Can we replace lifting? Those sorts of things. Second thing they did was they looked at how those tasks convert into jobs, because our jobs are sort of more than one task typically, and so is it going to replace the whole job? Is it going to replace part of the job? What does that look like? And the third thing they looked at is the economic benefits of automating the tasks, because you could automate almost anything if you're willing to pay that much for it. So they tried to restrict it to things that they thought would work. Now, obviously, there is uncertainty in each of those components of the model. Frey and Osborne did a very nice piece of work putting good uncertainty around the first piece of this. So they did a lot of work with experts looking at which technologies might actually develop in the right way to be adopted, but they didn't, and then they did put some conversion of those technologies into jobs. They sort of assumed that the economy would stay the economy. So we looked at that and said, that's great. I mean, that's a good piece of work. But what are the bits that are missing? What are the assumptions here? And there's two big assumptions that troubled us. The first one is, it assumes that if you can automate a task, you will automate a task. And we wondered whether that was actually going to be true. And the second assumption is it assumes that automation is used to replace human labour. So there's an assumption of substitution here. So we thought, hold on, let's step back. What do we actually know about technology adoption? And we looked at what was missing, and it's this idea of technological frames, which was an idea by Wanda Olakowski. And a technological frame is sort of how we interpret a technology for use. So it guides our assessment of whether something's useful, whether it's not useful, how we'll adopt it. That sounds very sort of esoteric, so here's an example. Here's a technology being used. It's being used by a dog, but it's still being used. And that technology has been around for about 100 years. And what the dog is doing is it's listening, it's receiving information from that technology. Here is an upgraded version of the technology. And actually, the fundamental is very similar. You know, you produce an analog sound from a thing that goes around. The reproduction technology is slightly different. It sounds better. But the underlying use is absolutely profoundly different, which is the dog is listening. The DJ is a performer. He's using his technology as an instrument rather than an instrument for performance. And so it sort of matters how we interpret the technology that we're working with and the way in which we adopt it. So we thought it would be quite interesting to understand a little bit more about what that looks like. This is a model by, I forgot to put the reference on here, it's Kaplan and Triptas in 2008. And they looked at how those technological frames emerge and how they're used in technology adoption. And they see it as a sort of relationship between multiple users. So they look at the producers, the users, and then the institutions within which technology is adopted. They look at the technology trajectory and the interaction between those two things. So why do we make turntables with 2 turntables instead of 1? It's because there are already users who are saying, well, actually it'd be quite good to use it as a musical instrument instead of using it as something to receive. So there is a two-way interaction. We shape the trajectory of technological development as well as taking it. And also the collective technological frame, so what our shared perspective of what technology is for, arises partly from the interaction between the multiple groups involved and partly from the trajectory of the technology. So this is a dynamic system. And we thought, well, this is relevant. Perhaps we ought to understand a little bit more, before we start saying machines are taking our jobs, let's understand a little bit more about how users, how the people making the decisions to adopt technology might be approaching this. Now, I love technological framing, but you can't, the technology of automation is too big to frame using this particular method. So what we did instead was we looked at decisions to automate in general, and then said, actually, as a second order, we ought to start to disaggregate this a bit and start to think about the specific framing for technologies. So we did my favourite thing, critical incident technique interviews, to understand how decision makers had chosen to automate processes that were involved human interaction. So we interviewed 10 senior managers. Obviously, all of them had made more than one automation decision, because we ended up with 21 decisions. We interviewed in UK, Belgium, France, so it's sort of the same kind of economic and industrial environment. They were quite senior, a lot of operations directors in there, site managers, so we're managing very big locations with a lot of tech in them, some technical directors, and some other senior executives that have been involved in automation. And we chose a range of industries, just we want to get a sort of big picture of what's going on. So we've got some service industries in there, we've got call centres, we've got insurance, but we've also got things like high-tech aerospace manufacturing, we've got logistics centres, so Amazon-looking warehouses. I'm sure we've all seen pictures of robots in warehouses, or maybe it's just the stuff I read. But the engineers speaking. though we looked at this range just to get us a big picture of what could possibly be going on. First thing we found is that the executives thought about technology adoption in three quite distinct ways in relationship to people. First of all, they do some job substitution. There are some jobs that are boring or repetitive or dangerous, where it makes sense to completely automate a process. And it does lead to loss of skill, it does lead to loss of knowledge, it does lead to reduced headcount. And the managers were not entirely upbeat about these. So they're like, yeah, it's great that we've saved some money, but at the same time, sometimes we're exposed to more risk because we don't fully understand the process. We might be in a situation where we've sort of forgotten that valve over there is really important and we shouldn't mess with it. So there was definitely a downside beyond the human cost of it, but they were reflective about the human cost. The second thought was about job enhancement. So we take the routine work out so that people can focus on higher value-added work. This may require new or enhanced skills. So an example of this was automating some of the back office functions in an insurance company. So you've got a load of people doing kind of quite boring clerking activity. The computer does that now, so they can spend more time talking to customers, being helpful. That particular introduction didn't result in any loss of jobs, but it did result in an awful lot of retraining, because those are very, very, very different activities for people to be carrying out. And the third thing, which we've never seen in any other piece of work on this, was sometimes, as obvious as it is, people don't automate. No, that's not how we want to compete. They may decide that actually it's differentiating to have people. They may decide it gives them some flexibility. So an example of this was a logistics centre, so warehousing. They do order fulfillment for big mail order companies, that sort of thing. And they said, well, actually, if we automate this, it commits us to a certain capacity and size. And if you look at order loads, it's very seasonally variable. We're in an area of relatively high unemployment. The 6 weeks before Christmas really matter because it's heavy demand and people would like to earn some money before Christmas. There is actually quite a lot of sense in not filling the place with robots where the utilisation is going to be variable, and it also changes our relationship with the local community. So they were quite thoughtful about the non-economic or the social aspects of each of these choices. Now, this is qualitative data. So this is qualitative data that I've counted. It is not quantitative data. You should not think about this as in any way representative. Big health warnings on this. I should put a big sticker on there saying health warning. But we found that in 4 out of our 21 decisions, so around about 20%, they didn't automate at all. So this is it's quite a significant thing that's missing from the models. And in the difference between enhancement and substitution, it was around about half and half. So if you add the no-go to the enhancement, you see that the idea of robots just coming in, robots automation just coming in and replacing kind of one-for-one human labour, is the minority situation rather than the majority situation in these automation decisions, at least in this particular sample. So that's got some quite important implications. First of all, it means that if this was normal, and I'm not claiming that it is, the forecasts of job losses could be out by a factor of 2, which, considering the enormity of the decisions that are being made based on them, seems important. The second thing is that the no-go decisions are material, and they're not included in any of the models we've seen, and it's worth challenging the assumption that if a technology is available, it will be used. And the third one is that in terms of preparation, and many of us are kind of educators in this room, we need to be thinking about how we prepare for job enhancement as well as job substitution. And what should we be doing to help people adjust to this challenge, which is sort of definitely on the horizon. So the second, one of the things I like about critical incident technique is because you get people to talk about something that's actually happened, they tend to, yes, there is retrospective sense making and that can be problematic, but they tend to reflect quite a lot on what else was going on around them at the time and what's important to them. And there were 4 sort of recurrent themes from these interviews. The first one is the sectoral context is very, very important. Now, most of the models we've seen are attempting to be kind of global and top-down, and actually, the way managers think is in terms of the competitive intensity and regulation in their own sector. So it's not that we should necessarily expect a whole bunch of sort of evenly distributed automation decisions across the world. We might see this flicking sort of sector by sector, and so, you know, in terms of modelling, we could be a lot more refined about this. Second thing is that talent markets are specific and local, and it can be important both operationally and socially to retain people. Now, we did our work in England, France, Belgium. At the same time, one of our colleagues was doing work in South Africa, where you actually try and create more jobs when you're putting automation in, because they have a terrible problem with unemployment. So, you know, if you're looking, I was doing some work with construction engineers at the time, and they try and design for maximum labour, which is kind of the opposite of what you would do in the UK. And so, understanding that sort of quite granular specifics of talent markets is not built into the models at the moment, maybe it should be. The third thing is that, as I say, most of the managers we spoke to have been involved in multiple, you know, waves of automation, and they care a lot about how successful the previous one was. If you're good at doing this, you'll keep doing it. If you're not good at doing it, you'll be really thoughtful about what you might see as wasting money again. And so, again, related to sectors, we might see that people resist what's called first mover advantage, because you want to learn from the mistakes someone else made instead of the very expensive mistake that you made. So organisational trajectory turns out to be really important in this. The final thing is they were very reflective, more than we expected, on the broader impact on society of what they were talking about. So they said, you know, and in fact there were sort of two quite polar views. There were some people who definitely had the kind of we're doomed view, and that there were professions that should rethink their future. There were other people that said, yeah, it's kind of creative destruction that'll be good, it'll create opportunities. But the implication of that is there will be winners and losers, and you need to think about what it takes to be not the losers. One of them rather memorably said, well, the introduction of the motor car was extremely good for horses. Their lives are much more comfortable now, but there's a lot fewer of them, which was a sobering moment for all of us. So this has some implications for practice. Automation's become a strategic issue. It's not necessarily something you should just be doing at the plant level. We feel maybe it should be elevated within some organisations, and it would be a lot of these. We talked a lot this morning about cost-benefit analysis. A lot of these decisions basically made on kind of, you know, does it have a 2 to 5 year payback? People are not really using approaches to strategy making under uncertainty for many of these decisions, and this would be a really good application for it. So we would definitely encourage people to think a lot more about things like scenario planning. Winners and losers, but the impact of automation is going to vary substantially by sector. So top-down models aren't particularly helpful. Bottom-up ones might be really helpful, and we could get a lot more granular about sort of, you know, specifics of the sector and the geography in which these decisions are being taken. And policy makers, you know, as a sort of corollary to that, need to be paying attention to how those play out in the different sectors and the different geographies, and the educational requirements that are supported with this. The one thing everybody said is education is the one thing that will get us through this. By which I think they mostly meant education of other people, not themselves. Yeah, what can I say? It also has implications for research. The global underestimates, so I think, you know, Frey and Osborne with their sort of estimate of 47% of North Americans were actually very thoughtful, and they put a lot of caveats in their paper, but those have not been picked up in subsequent papers to the same extent. And certainly outside the academic world, you know, we're not picking up that specificity about automation choices and technology use in some of the things we're seeing in the media. So we think that those sort of, you know, thoughtful and well-developed macroeconomic models could be improved by more contextual qualitative research. And I know I would say that, wouldn't I? But I do think it's actually the case. And we saw technological frames as one of the lenses to it. Obviously, others are available. There are, of course, some barriers to modelers and qualitative work or researchers working together. We're trained in different ways, but there are skill differences. there are epistemological differences, amusingly about the nature of uncertainty, but we go in and we say, well, we did these interviews, and the modelers say, well, that's all very subjective, isn't it? And I said, well, have you looked at your data? But it's, we need to find ways to bridge those particular gaps, and I think that's one of the things that CRUISSE is for, and it would be very interesting to continue that particular discussion. Thank you for your attention.